So hello, I apologize for the glitch. So now I'm doing the lab with screen sharing. Sorry for that. Okay, so once again, so we are essentially looking at S5 lab R&D. If you knit it as a PDF, you essentially what you see is the PDF file that I have posted also to the lab tab on Blackboard. It was a mistake from my end. So if you're looking now at this PDF file, you essentially can see at the very end of the PDF what the assignment essentially is. What is being asked from you is essentially to submit what was done during the lab. What is asked from you is to essentially reproduce all the steps that were done here with the fitting of this linear regression. So essentially what we do is to go at the very end of the R&D file, build a new chunk that essentially will now allow for you to fit this file. So we can, for this purpose, we can, so it's important, and this was something that Paul, I believe you have put forward. So you always need to build these R chunks to run it within the fitted environment within the RMD file in the output that you can knit it. So now essentially we will go and fit a linear regression. So we can now, again, load the mtcars data file. mtcars. So now we have the mtcars data file. We can now have a look at mtcars, and we know already how that looks like. So we can build now any relationship that we want to build. So we can, for example, we build fit one. Let's do fit two. LM can be miles per gallon as a function of HP, for example, data equals mtcars. So now we essentially get as an output, we get this fits two. With summary, we can call it, we can display it. Summary fit two. We can now depict it. So we see here that there's a significant relationship, which is indicated here with the p-value smaller than 5% with a significant t-value. And in addition, corroborated with the 3 asterisk. So we essentially get horsepower predicts miles per gallon in an inverse fashion. So the greater the horsepower, the smaller the miles per gallon, which is quite intuitive, right? So now we want to depict this relationship. We can do this by drawing a scatter plot, which we have done in the lab. So we can plot mtcars, miles per gallon as a function of mtcars horsepower. This will give us a scatter plot that you see here. It is a rather nonlinear relationship. That's for now not relevant to look at. Appline fit two. Oops. Okay, so one thing is important that you always run it in once if you do it in the RMD file. So now you essentially see here the fit line. So now we can so now we want to manually calculate these fits. So we can essentially do that with the formula. We can now, again, in a new chunk, we can build y hat 0, just like in the lab. This is our predict fit 1. Oh, it's fit 2, obviously. So now we get here the fitted value, right? So we essentially look here at if you are looking here at the y-axis and the x-axis, this fit2, the predict function, will give you the predicted values on the y-axis. So y hat 0 is now the prediction of fit2. So y hat 1 gives you now fitted fit 1. Again, fit 1. It's obviously it's fits 2. And this essentially gives you the same fitted values. So if we want to calculate this now, the y hat 2. So we're seeing now that the coefficient of fit 2, coef fit 2, number 1, this is the coefficient that is essentially the one from the fit, right? So if we are to predict, it's larger. This is the plot. Let's move this down. Let me see it right in the context of this chunk. So here we have coefficient 1 will be the 30.1, which essentially is here in the console, the intercept. If we are adding to this now, our coefficient fits 2, which is here our slope, we're adding this plus coef fits 2, which is now essentially our slope, right? This is the horsepower. And we're multiplying this with MT cars. Horsepower. This essentially gives us now a list for each entry. We are essentially taking now the X values and we're multiplying this with the coefficient. So this essentially gives us y hat 2, and y hat 2 is thus consequently essentially what the prediction shows. So we're confirming, just like being asked on the last chip, that's like manually calculate coefficient using the formula below and compare with the model's output. So if we're calculating now beta 1 we are getting here a y mean. This is calculation of the total sum of squares, the regression sum of squares, and the residual sum of squares. If we are to calculate the coefficient now by hand, we need to do a calculation of the mean, which is x mean, which is now the mean of NT cars horsepower, which is here 146.6875. If we are taking now on the x, this is NT cars horsepower. This will be our x, and y is our NT cars miles per gallon, right? So the beta one essentially, following this formula, we're building the product of the deviations from the means, and then the xi minus x bar squared, so the sum of squares is now essentially beta one sum x minus x mean multiplied by y minus y mean. And we're dividing this by the sum of squares, which is x minus x mean squared. This is our beta one. So again, in the chunk, we need to run this together. We need to make sure, obviously, we're using the same. Okay. Oh, oops. Obviously, we also need to build the y mean. The y mean is mean of NT cars miles per gallon. So now running the whole thing in total gives us a beta one of minus 0.06, which is essentially what we need. So now in the same fashion, we're calculating now the beta zero, which essentially is y mean minus beta one multiplied by x mean. And this beta zero is now 30.01. So this essentially is the deviation from our is the y mean minus the coefficient multiplied by the mean of x, which essentially arithmetically needs to lead to the intercept. So this is essentially the solution. To calculate the left-hand side here, would then need, if we're taking the left-hand side here, arithmetically, we need to once again confirm that the left-hand side of this equation needs to be close to zero, because arithmetically we have here the y hat, which is the fitted means, right? Minus y bar. yi minus y hat should be close to zero. So this essentially should be the fitted value. So y hat 0 minus y mean multiplied by y hat 0 minus, oh no, wrong, y minus y hat 0, right? And this should essentially be, what happened here? That is not what this means. Not sure what this is doing now. Just a second. I had 0. Okay, let's do y hat 2. So this should now essentially, if we sum this up, be close to 0. So sum of y hat 2. Okay. Pressing the whole thing in bracket. Okay. And this is fairly close to 0. So what does this mean? So we have y hat 2, which are our fitted values, right? Which we have seen for all the cars. Y mean is the mean of y. And y minus y hat 2 should also be not deviating much from what we essentially see. So this is basically, if we are summing this up, this should arithmetically lead to balance this out between the y hat 2 y mean and the y minus y hat 2. So this is fairly close to 0. And the reason why it's not entirely close to 0 is because of rounding differences between the groups. So this in total was asked from you. If you're knitting an example like that, and maybe just for the sake of argument, take a different variable, just make sure that you are essentially on board with what has been done here. And make sure to submit this, please, to Blackboard. So I've extended the deadline because I understand that there was a glitch from my end. So take more time, and please make sure that you understand what is being done with each of these exercises, each of these separate parts. And yeah, just waiting until the PDF comes out. It should be here in a second. So for those of you that can't run the PDFs, please just run it as an HTML. The outcome is the same. Okay, I hope this was, I don't know what the PDF is, it should come out in a second. Yeah, there we go. So here's this exercise. Please feel free to use the same variable, but I encourage you to use a different variable, just for the sake of that you have done it with your own example. And it's really, this is basically where you're testing your own insights. Yeah, good luck with that. I will post a recording of next lecture tomorrow.